All right, in this video, I just wanted to look once more at that key idea of being able to solve a polynomial equation. It's kind of the same as finding the zeros of a polynomial function. It's just this one's already set equal to 0. All right, so your process here would be to think of all the possible rational roots, and you do that. The possible rational roots is the place to start. You got to find one nice one that works. All right, so what you would do to find those is you would take the factors of the constant term, doesn't matter about the negative because you do plus or minus on all of them, divided by the factors of the leading coefficient, which is 1. So as we try to factor 85, we know 1 goes into it, we know 5 goes into it. 6, 7, 8 doesn't. When we get to 9, we're about at halfway, square root, of it. So we don't really have to go much further. So now I'm just going to take the match to the 5 and the match to the 85. And then don't forget you have to do plus or minus on all of them. So these are all potential nice roots. We want to find one that works. Once we get one that works, we're done with all the synthetic division and the testing, okay? So you just get started. So let's put 1 in the box. Okay. Leave a little space. Go and test it. See if it works. And the second you see that it's not, like right there, I can tell it's not. I'm going to abandon that. I'm going to try -1. All right. So I'm going to go in here and see if -1 works. What is that, 71? Nope, that one's done. So this one's done. I know these two don't work. So now I'm going to try 5. And this process, it doesn't mean you're doing anything wrong when it takes you a while. It's just, there's no way to know real quick which one of these is going to work just by looking at it. So let's try this one. 15. Oh, okay, this one works. All right, now, once you get one that works, you're done with all this testing process on this one because this problem was degree 3. Okay. So this one had, I don't know why. Okay, so this one had degree 3. So you know it's going to have 3 zeros, 3 roots. So if you can get one that works, here it is, then what you've got remaining are the A, the B, and the C of your quadratic. See that 5 corresponds to a factor of x minus 5, and this right here corresponds to 1x squared minus 8x plus 17. Okay, so what you've basically got is the original polynomial now is factored into these two factors. So you don't have to show this part, but this is kind of the concept that's going on. And so now we just need to solve the quadratic. We already know this one, right? Now we just need to get the other two solutions from here. So this one doesn't factor since 1 and 17, can't use that to get the 8. So what I'm going to do is opposite of B, go in and use the quadratic formula. So let me get all that set up. Okay, and then we'll finish working out the quadratic formula. So we have an 8 there, a 2 there, and under the radical I have a 64 and then minus 68. So I actually get a negative underneath the radical, -4. So that means I'm going to have imaginary solutions. So this is 8 plus or minus 2i all over 2. And then when you divide, because since 2 goes into everything, 2 is a factor all the way through, you're going to get 4 plus or minus I for the other two solutions. Okay. All right. So when you put your answer in, sometimes it'll say, no, on this one, we did them all. So we'll have to include the 5. And so your answer would be the 5 and then the 4 plus I and the 4 minus I. And they should let you write it with the plus or minus and not have to write it out separately. Okay, so that's just a reminder of the key problem when you're trying to solve a polynomial equation. Okay, so let me